Hello, myself Sagar, and I am pursuing my Masters in Mahindra University in Computer Structural Engineering, and I am going to give my Infrastructural Health Monitoring Course project presentation on damage detection of a steel frame under the guidance of Visalakshi, Talakokula. Coming for the introduction, continuous health monitoring and assessing the health of the structure is nothing but infrastructural health monitoring, and we are doing this early damage detection of the structure and improve safety and cost savings and increase efficiency. In this, we are using TZT. We are using TZT because it has ability to convert mechanical energy into electrical signals or frequencies, and we are using LCR meter. It is used as to measure the impedance, conductance and resistance. And in this, I am using a steel structure because of it has more strength and durability, and its structural integrity and design flexibility and speed of construction will be more, and it is sustainable and the maintenance will be less. And coming for the materials used, this is the soldering equipment, and this is acetone, epoxy, lead and PZT sensor are used in this project, and that is LCR meter, and we use nut bolts and the PZT sensor of 10 into 10 into 0.3, and this is the frame structure. This is the L section which I have used to fabricate this frame, and this is the frame which I have fabricated, and total it is connected by bolts, and there are 9 small bolts, and remaining all are 8 mm bolts which I am used. And here we can see the piezo sensors which we have placed attached to it, bonded, and we have soldered the coaxial wires for it, and it is connected to a LCR meter. This is the LCR meter we are using, and for using that we are using Wipro software, and we are taking the healthy state reading. As I have bonded the piezo sensor to the structure and soldered the one side of the coaxial wires, and other side of the coaxial wires were connected to the crocodile wires, and which is connected to the LCR meter, and it is shown in this Wipro software interface. And now I am running this file. We can see the baseline signature of the structure, which is shown in this Wipro software interface, and we have took from 150 kN to 400 kN with the step of 100 kN. The frequency is 150 to 400. It took couple of minutes to run this total frequency ranges of baseline signature, and this is the conductance and this is the susceptance values of this structure. And coming for the objectives, I have 4 objectives for my project. First is the identification of damage, and to determine the location of damage and severity, and to determine the remaining service life of the structure. As now we are seeing this healthy state structure, and these are two different sizes of bolts which I have used, and for larger size of bolts we required 8 rotations to loosen the bolts, and I am inducing damage by loosening of bolts. For small bolts we are using 4 rotations. This is 1 rotation, and I am doing second rotation. Like this I am doing. There are total 3 levels of damages I am inducing. The first level of damage is loosening of 1 bolt, and second level of damage is loosening of 2 bolts, and third level of damage is by doing of 3 bolts loosening. Just like healthy state reading, and we are taking the damage level 1 readings. Here we can see the conductance and susceptance values of damage level 1. As we have seen the healthy state and damage state readings, then we will do the same as damage 2 and damage 3, and from that we will get the Excel sheet, and in that this is iterations, number of iterations, these are conductance and this is susceptance values, for all healthy state, damage state 1, 2 and 3 for sensor 1. Like that we will do for all 4 sensors. And we will do we will find the identification of damages. These are all the plots which we have kept from conductance of all 3 damages and 4 sensors. And this is a healthy state, damage level 1, 2 and 3. This is sensor 1, 2, 3, 4. These are RMSD values which we have obtained from previous plots, and this is for level damage 1 level, 2 and 3 level, 3 levels of damage. And here in this we can see the location and severity of the damages. For damage level 1 we can see near sensor 2, and for damage 2 we can see at sensor 4 and sensor 1, and we can see damage 3 at sensor 4 and sensor 1, and severity is more at sensor 4, which we can see here it is approximately 16, and it is near sensor 2 for damage level 1. Coming to the final objective, the remaining life of the structure by using this formula, and this n by n naught means number of rotations for damage and total number of rotations for the structural failure. And I have did like 12 rotations of is my damage, and 268 was the final damage to collapse the structure, and I am getting the remaining life of the structure is 95%. Thank you.